So yesterday we stopped at somewhere here. So just a refresh how you solve quadratic equation. You use the x equal to minus b square root b squared minus 4ac divided by 2a. All right. And then I equal to square root minus 1, which is the yesterday equation. Right. Okay. So yesterday we also cover Cartesian Argand diagram. Okay. So you will see this Argand diagram in your static and dynamic class later on. Or I'm not sure about the digital, not digital, control theory, I'm not sure, but you will see this one in your electrical classes. Okay. Today we go into addition and subtraction of complex number. So meaning we add two complex number together, and there is a procedure. Yeah? So we know that there is a polar complex number and Cartesian complex number. So we will do Cartesian first, then we do polar. So let's say we have two complex number, z1 equal to a plus jb, and z2 equal to c plus jd. Right? So a is a real number, b is a imaginary number, c real number, jd equal to imaginary number. So let's say we want to add these two numbers. So the general equation, you take z1 plus z2, and then you copy the equation. Right? So you add the real part together, a plus c, and then you add the imaginary part together. Okay? As long as the dimension is correct, means the real dimension and imaginary dimension you add together. Okay, this is Cartesian, right? Same with the subtraction, right? Same with the subtraction. So you take the real part or real component, you minus, and then the imaginary also you minus. So this will be the general. If the question asks you to add or plus. Okay, okay. So yeah. Okay. Now, how do we represent the addition and subtraction on the Argand diagram? Or in other subject, you might see it as a vector diagram, right? So let's say we have two vector, right? So let's say we have a graph like this, right? So you have a real axis and imaginary axis. And you have the first complex number, which is 2 plus j3 or 3j. So you draw on the Argand diagram. So 2 means go to the real axis 2, and then plus 3 will go up here. So you need to draw the direction. Yeah? You can see it as a vector. So you need to draw the arrow pointing from the origin to the location of the 2 plus j3. Okay. And remember on the Argand diagram, we have 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. Okay. Second complex number represented by 3 minus j4. So you go to 3 minus 4, represented by vector OQ. Okay. So vector OQ is in quadrant number 4. So if you need to add two vectors together or two complex number together, so basically you add OP and OQ. So it will be, you need to write, if you ask you to given two vector or two complex number, you write, you need to draw on the Argand diagram, and then you need to label accordingly, right? So if the question asks you that let's say 2 plus j3 represented by vector OP on your Argand diagram, you need to use OP to represent 2 plus j3. You need to label your Argand diagram O and P. Huh? So these are some habit lah, when we solve assessment problems. Okay, so if it's addition, means you add two complex number together, OP plus OQ equal to one vector, right? So so on the graph, if you plot on the graph, you should able to see it will landed at 5 minus j. So by mental calculation, if it's addition, means you add the real part together, 2 plus 3, you get 5. 3 minus 4, you get minus 1. So 5 minus 1j. 5, you go to real, 0 to 5, then go down, 1. So you get this point, and you plot OR, okay? And you join by using the dotted line. Okay? So this is how you do. And how you draw the parallelogram, you already learned in previously, right? So important is you know how to calculate the location of that vector diagram. Okay, so this is quite direct. Huh? So mathematically, you do it like this. 2 plus j3 plus then bracket 3 minus j4. Okay. For complex number, remember to use bracket to represent the vector. If not, if you open up the bracket, it will be very confusing when reading your answer. Okay, so this one should be okay. So if you want to represent some vector as a reverse vector, for example, OQ just now, OQ, 3 minus j4, you want to represent as a reverse vector. Quadrant 4, flip to quadrant 2, okay, like this. So you can do it as a negative sign in front the bracket vector. Okay, so you can add a minus in front the vector, means you reverse the vector. Okay, so in static or dynamic, positive means go along the x direction or the object movement. Always follow the movement of the vehicle or stone or object. So if the object move to the front, this direction, then means you mark that direction as positive. If you reverse, then you mark as negative. Okay. Okay. So when you put a negative sign in front of the complex number, 3 minus j4 will become minus 3 plus j4. Okay. Okay. Something wrong on my slide. This one, OQ should be put here. Error on my slides. Okay, it should be like this. Okay, now just now the notation is a bit rented. So if you put a comma, means it's another side of that vector, right? So when you take OP minus OQ, OP, Minus OQ means you reverse this direction to this dotted line here. You can write as OP plus OQ comma. OQ comma equal to the new vector which is represented by OS. Okay. So in the mathematics, if you don't know there's a OS, you can just put a parameter, right? Put a X or put something XYZ, something like that, if you don't know, right? So if you take OP minus OQ, OP is 2 plus J3, you minus OQ is 3 minus J4. You take the real part together, 2 minus 3, you get minus 1. Then look at the imaginary component, 3 minus 4, you get minus, minus 4, you get positive. So you get plus J7. Okay. Then you draw on the Argand diagram. Minus 1, you go to the real side. 5 minus 1, then go up 7. Remember to draw the arrowhead. The arrowhead is from O to the S point. You draw the dotted line to complete the parallelogram. Okay. Okay, this is addition and subtraction. Okay, let's do a small exercise. You're given two complex numbers. Z1 equal to 2 plus J4 and Z2 equal to 3 minus J. The question asks you to find Z1 plus Z2, Z1 minus Z2, and Z2 minus Z1, and show the result on the Argand diagram. See if you're able to solve this one. Yeah? So first, you need to draw the Argand diagram. So for exercise, you don't need to like chun chun. You don't need to on the scale. In exam, please use your ruler scale to mark the scale of the axis. Okay, so Z1 is 2, 4. Z2 is 3 minus J. Okay. So the question A will ask you to combine Z1 and Z2. So you do A. And for your exam, please start to use pen. Some of you, your assignment, you use pencil. So you need to start using pen for your answer, your assignment. Okay, Z1 plus Z2 equal. You need to write copy bracket 2 plus J4 plus 3 minus J. So equal to what? 5 plus J3. So you on the graph here, you mark 5, then 3. About here. And use your ruler. Okay. Then label this one as maybe just label this one as A. Okay, you do the same for B. Z1 minus Z2. 2 plus J4 minus 3 minus J. You will get minus 1 plus J5. Okay, so minus 1 will be on quadrant 2. Minus 1, J5. Okay, correct, correct. Yes. So basically you are flipping Z2. So this is minus Z2. Okay, do the same for C. Minus 5J. Z2 minus Z1, so it's 1 minus 5J. J5 or 5J. Going somewhere? You're lost, eh? Okay. So, yeah. So this is C, yeah? Okay, in test, you only need to show me the final answer. Where is you just need to label A, B, C on the graph with the correct scale of your axis. Okay, on graph you can use pencil to draw. Right? Then you need to use pencil. Right? Uh, for test 1, test 2, no. You will be given a blank A4 paper. Final, I need to check with department. Yeah. On the answer script there. Lah. Okay, so these are the standard steps lah. So we are expecting you to draw all these vector on the graph. Yeah, a proper way of writing is to write the vector not vector, write the complex number at the arrowhead there. Yeah. But if you're lazy, you follow the question, you can do the same as what I did on the whiteboard. You can just label the vector as A, B, and C. Yeah. So we have done addition and subtraction. Easy, right? Easy, right? Okay, so multiplication and division. This will be start your careless mistakes happening when they come to multiplication division. Okay, so remember that I2, J2 will equal to -1 in this case, because when you multiply, you will multiply the J or I 2 times. So let's say we take A plus JB multiplied by C plus JD. It's like a quadratic equation or multiply the 2 factor. So you'll get AC and then AJD plus JB, CJB, and then double J and BD. Yeah. Who don't understand here? Who is lost at here? No, huh? Okay. So this is just a normal multiplication. So then after that, you rearrange. Okay, rearrange, group the, sorry, typo error again. This is not J2, it's J square. Okay. In your test also, your writing also important. If you write J2 here means something wrong. I circle this one, put question mark. Why? Where you get 2? Okay. It's actually J square lah, J square. And then yeah. J square equal to -1. Remember this one changed to minus BD already. So change, put inside the bracket, means you put in the format with the real part and imaginary part. Okay. So from your assignment, I can see most of you able to do your answer very organized, which is very good. Okay. So you need to write all these like J square -1. These are all bonus mark, or we can say as it's a free mark actually. You write this one, you got marks. You don't write that one, you don't have marks. Okay. Okay. So if you take these 2 examples, you take 3 plus J2, 4 minus 5, you will get this answer, 22 minus J7. Okay, is it correct? Correct, okay. But anyone have question on the general equation, this one? All right. So if you understand this one, just the rest is just application and substitution of value. Careless mistakes is always the J square here. Especially positive, no problem. Especially the question is give you negative. Negative become positive. This will be the careless mistake part when you carry to the next steps. Okay. Yesterday we also mentioned something called conjugate. Right? Conjugate. So conjugate means you have a negative sign. So if you're A plus JB, the conjugate will be A minus JB. It's a opposite of the imaginary part. Yeah, conjugate. Yeah, we are changing the imaginary part, not the real part. It's called conjugate. Conjugate appeared is to cancel out some mathematic calculation. Like yesterday we saw, we cancel the minus J in the denominator part. Remember yesterday? Yeah. So it's part of the strategy solving mathematics question. Okay. So if you take conjugate, multiply itself, means if you have a 3 plus J4 and you multiply with its conjugate, basically if you have A plus B multiplied by A minus B, what you get? Never mind. We use this one as your example, or we can use the general equation. If you multiply, then so this one cancel. This one is what? -1, right? B square, sorry. Z square go -1, right? So this one become positive. So you get A square plus B square. So when you take conjugate multiply, basically you are removing the, not removing, but you are actually finding the square of the real part and imaginary part. Yes. So you actually cancel out the imaginary part lah. Okay. So you'll get real number. Okay. So this is just a reminder of your previous mathematics, advanced mathematics, right? If you take conjugate multiply by its own, then you will get the real number. You actually cancel out the imaginary part. Okay. So what is the application of this conjugate things is from the sensor, a sound sensor or noise cancelling devices, right? So how you cancel the noise means you take the opposite of that noise, right? So if you have 10 dB, you have negative dB, then you cancel out. So this is how noise cancelling devices work. Okay. So I think for mathematics, conjugate is to cancel out the denominator. Actually, we change the form of factor form or factorial form into a linear form. Means we don't want to see the denominator. So if we take this example, 2 minus j5 divided by j plus 3 plus j4. So in layman term, no one understand what actually this one mean. But why you take something and then you divide. Mathematics, it works, but you unable to tell to the normal people, right? So how we do is that we will multiply the denominator. We cancel out this we call factorial form into a linear form. Means we move the denominator to the top. Okay, so what we do is we multiply the same thing. Means you take this conjugate, 3 minus j4 conjugate is 3 minus j4. So you multiply its own, means 3 minus j4 divided by 3 minus j4 actually is 1. So this is the strategy in mathematics. Usually mathematicians, they like to create something out of space to cancel something. So actually this step, you see it in the previous class actually. Okay. So meaning in the test, when you see some factorial with the imaginary number in the denominator, the next step is to multiply the conjugate. You will see these steps in static dynamic or those chapter or those module that use complex number. So we assume you already know in Engineering Maths 1. So when you go to senior years, then the lecture will no longer mention this anymore. Okay, we assume you know. Okay, so when you expand, you know that plus multiply by the conjugate, you get the real number, right? So this one become 9, this one becomes 16, right? 9 plus 16 is 25, right? So you can expand the numerator. So you multiply the top and you multiply the bottom. So the top will become minus 14 minus j23. It's just a normal multiplication on the top. But below one, you know, is is 25. Is equal to a squared plus b squared. Right? So in exam, you don't straight away write 25. You need to show me how you get 25. So you need to show the steps. You need to show me the steps like this. In other subject other than mathematics, you don't need to write these steps. You straight away get 25, for example. So because you are this module is mathematics, you need to show mathematics steps. Okay, so from here you just combine them together and then you do the normal division. Real part divide, imaginary divide. Okay, so we combine together. 14 will divide by 25, 23 will divide by 25. And you can stop your answer here, but sometimes you see the question will mention keep your answer in 4 decimal place or 3 significant figure. Means you need to change this one into digit into point something. You need to read carefully the question. Sometimes they want you to do conversion. Okay. So this will be the thing lah. This one, you need to read the question. If the question didn't mention anything, you can stop here. If the question at the back, put your answer in 3 significant figure or 4 significant figure, then you need to write in the decimal place. Okay, so this is just an exercise for you guys. Maybe you can, A, B, I think easy for you. You try to do C. What is the answer? You're given Z1 equal to something, Z2 equal to something, Z3 equal to something, and all these are complex number in Cartesian form. Sometimes this kind of question will ask you to present your answer in the Argand diagram. Final answer on the Argand diagram. So C, you do the multiplication and addition first, like what you did previously. multiplication of Z1, Z2, you will get 13 minus J. Z1, Z2, you get minus 1, 2J. And you see this one as have a denominator or factorial format. Remember, the question actually asks you, want to test you whether you know how to use conjugate. Okay, I will jump to the third question. Okay. Apa? Plus 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 5Js Okay. Where's my error? This one, is it? This one salah. One should be 15, Yes, should be 15. Okay. So Z1, Z2 equal to 13 plus J11, correct? Correct. On the whiteboard wrong. Okay. So then you simplify it, right? You expand the equation. I mean, on my slide, I assume you know how to expand already. Means you expand this one. Right? Remember to put the bracket. When to put the bracket, it's plus, correct? This question actually tests you on the conjugate, means the one that I wrote on the whiteboard here. Right or wrong? Okay, let's test it. This one is what? This one is correct. Minus 1 plus 2J, correct? Okay. Wait. Let's do. Okay, so this one, Z1, Z2 is 13 plus, this one is wrong. This one 15, right? Okay, fine. I copy wrong, is it? Minus 1. 这个哈。Oh. Yeah, correct. Okay, this is minus 2 plus 5. Okay. Then correct already, right? And this one correct. Okay, let's do 11, 13 plus J11 minus 1 plus 2J. But the answer correct or not? Correct. You agree or not? This one or it's wrong? Salah kira. Salah kah? Okay, the bottom one is how many? Bottom one is 1 plus 4, right? It's 5. So correct this. Okay, the top one need to multiply. Minus 3 minus 6j minus j minus 2j square. So, hey. 13. Is it correct? Salah kah? 13 minus 26j. This one, right? This one 5, right? This one 5, right? This one 5, right? This one. J minus 2j squared. Oh, 11j. I copy salah. Sometimes I confuse with my own writing. Okay. 13 minus 26j minus 11j minus 22j square. So 13 plus 22. Correct. Negative. Sorry. J square into minus 1. Or negative. Pas kah? Then correct. Plus? Mana plus? This one? This one? Negative ah? Yeah. Okay. So you need to do the exercise. You know, like you see, you think you understand that sometimes when you write, you might find your own careless mistakes. Okay. So sometimes the question asks you to put in the decimal place or a few decimal place two meaningful number, significant figure, then you need to put in decimal lah. Okay. So sometimes the assignment in this module, I will just copy this question and ask you to submit the answer. So on my slide, sometimes I do not show you the steps. I just expand the equation, then I give you the answer. So, but in your assignment, you need to show me the steps. Yeah. Okay. This one is your homework lah. You go home and see whether you understand or not. Yeah. This kind of form B here is your test standard or your final exam standard lah. Will be you need to know how to multiply 2 and so on. Yeah. So this is your exercise lah, your exercise, and then the answer is here. Okay. So we have done multiplication and division. Let me see here. Complex number. Let me see your tutorial question. We are now at question 21. 21 lah. 21, right? Yeah. Total got how many? Tutorial question. Okay, we go one more, then we call it a day. We go one more. So multiplication, addition of complex number should be no issue, right? You just be careful on the when you copy the number. Like my mistakes is I always copy the wrong number, right? Okay, so if you have two complex numbers, they are equal. The real part are equal, and the imaginary parts are also equal. For example, you are given the two scenario, right? So in your static class or your other module class, you might be given Z1 and you don't know Z2, right? So let's say you have a complex number A plus JB. In the question, you know what is your Z1, but you don't know what is your Z2. You want to find your Z2. Your Z2 is C plus JD. Then you know that they are equal. This complex number, they are equal. This kind of question normally in the electromagnetic wave or in a mirroring application. Okay, so this is to solve the x and y. If you are given two complex number, left hand side and right hand side, you don't know the right hand side, you solve it x and y. Meaning you just expand the equation, then you mirror, you compare left hand side, right hand side. Then you find what is your x, what is your y. Okay, who don't know? This is quite direct. Okay, I show you, but the answer is on the screen. Okay, so it's just a comparison. Let's say the first one, you expand this one, the bracket here. Then you know the real part is 2x equal to 6. And then the imaginary part is J3. So your 2y equal to 3, 2x equal to 6. Then solve linear equation. Okay. Sometimes you may see quadratic equation. In your test or final exam, you will see quadratic equation on the left and some number on the right. Then you need to compare left and right. Okay. Yeah. Of course, this kind of standard you won't see in your test lah. It's very direct. Okay, you see the B. B example, you have two complex number, and then you compare left and right to find the A and B. Complex number, you work on two dimension. One, you solve real dimension, and then you solve imaginary dimension. Don't confuse the two dimension. Yeah. Okay, you expand, then you compare. In this case, you compare what is the real side. The real side is 4. B will be -7. Okay, careless mistakes always the J square equal -1. This part. Okay. So and then remember square root, you have positive negative answer. If you have square root, you have two root. You square root x equal to plus minus AB, plus minus A. If you have the x equation. Sorry. Yeah. Okay. So this the part B is actually ask you to solve two equation. Right? How you know you need to solve simultaneous equation? When you arrange, you will see real part. In this case, real part will be x and y. X and y equal to 2. And then the imaginary part will be 2y, 2x. Hey, something missing in my equation. Something missing in my equation. Yes, correct. Okay. J2y and minus 3x equal to 3, something like this. Okay. So you put the imaginary part together. So you have two equations. So this one back to your chapter 1 skill, solving simultaneous equation. Okay, so this will be your practice exercise. Okay. You will be start seeing this one omega L, this one in your circuit design class. Right. We stop at Cartesian complex number. Okay. We continue next week into polar. Okay. Right, we dismiss our class here. Remember to sign your attendance.